In this video, we're going to go through more about insulin. We're going to talk about how insulin is used in the body. What does insulin do? We've talked already in the first video about where insulin comes from. In the second video, we talked a little bit about glucose and why we need glucose in the cells. If you've missed out on that, be sure to go back and check those out. And I would really recommend, if you have a few extra minutes, to look at the second video about glucose and metabolism. It's probably not necessary for your degree or your test that you're studying for, but if you understand that, it's going to help you understand this a whole lot more. When we talk about diabetes and nursing programs, I find it can be this conglomeration of information, and it can be really, really overwhelming. And so what I learned to do quite early on was to start with the basic player. And when we're talking about diabetes, the basic player is insulin. Because diabetes, when we get down to it, you're going to learn that diabetes is really a problem with insulin production or insulin utilization. So understanding exactly what insulin does is going to be a huge jumping off point for understanding the rest of this unit. This video is a little bit longer. I think it's 12-13 minutes, but I promise you, if you spend the time and understand what insulin does, it's going to help you to understand the rest of this unit. We start talking about counter-regulatory hormones like glucagon, and we start talking about gluc receptors and glucose utilization. Okay, so here we go. So here's the problem. Here's where insulin comes into play. Oxygen, water. So if you look at all of the things inside of this kind of calculation I've showed you here, it's just a chemical equation, right? Glucose plus oxygen equals. So if you look inside that, or look at that, the molecules, oxygen, water, and carbon dioxide molecules have no problem passing in and out of a cell through osmosis. Unfortunately, glucose cannot do that. And so glucose needs a channel or a transport or a receptor or something to help it get through the cell membrane and into the cell. All of this stuff happens inside of the cells. That's why it's called cellular respiration, right? So here's where insulin comes into play. If you take a look at this kind of little diagram we've got here, you'll see that there is a glucose channel right here on this cell. But the glucose channel is closed, and the glucose that's outside of the cell is unable to travel inside of the cell to do its job. So what we need on these particular cells is for insulin to come and attach to the insulin receptor on the cell. So every cell is going to have more than one, obviously, insulin receptor and glucose channel, glucose transporter. There's going to be a number of those on each cell. But the basic action is that when the insulin attaches to this receptor, it starts this kind of whole cascade of events that ends up, if you want to think of it as kind of just opening this glucose channel door, that can help. I'm not a huge fan of the whole key and lock metaphor because it does break down fairly quickly, but if you want, you can think of insulin as the key, the insulin receptor as the keyhole, and then the glucose receptor as the door. And so the insulin attaches to the insulin receptor and opens the door and allows the glucose into the cell. So you can kind of see that happening over here. So remember I said what's really important to remember is that insulin, its job and what it wants to do is to move glucose out of the blood, right? If you remember that, you're not going to have any problems figuring out what glucose does or what glucagon does in the body. So let's start right here with what does insulin do? It assists, that we've just talked about, it assists the body in using glucose to synthesize energy, fats, protein, and store them as glycogen. That's kind of seems like a little bit confusing, right? So let's look down here. The first thing that insulin does in the body is it performs glycolysis. If that seems like a familiar word, it is, because again, it's the first step of that cellular respiration. So what it's doing is it's taking the glucose that's in the blood and it's using it to create energy. So no longer will that glucose be in the blood because it's been broken down and combined with other things and turned into energy. So that's kind of one of the ways that insulin gets glucose out of the blood. Another way is through glycogenesis. If you break that down, you've got genesis, which is to create something or make something new. And then you have glycogen, which is glycogen. And so this word means the creation of glycogen. So one of the ways that insulin gets glucose out of the blood is by taking these molecule, like one glucose molecule, and stringing them together into a string. They attach to each other kind of like this and create this string of glucose that when it's in this string form, it's called glycogen. And the reason we need it in that string is because when it's in this string, it's able to be stored in the liver and used later when we need it. So again, glycogenesis is taking the glucose that's in the blood, taking it out of the blood, turning it into glycogen, and then storing it in the liver. So it's pushing it away into the liver, taking it out of the blood. So again, that's another case where insulin is taking glucose out of the blood. If you look at this third point here, it talks about an increase of glucose uptake in fat in order to make glycerol. Glycerol is, remember when we talked about that triglyceride molecule, and we talked about how the backbone is glycerol, right? So we actually use glucose to make that. But really, when you think about it, it's just another way of taking glucose out of the blood and storing it. Only instead of storing it this time in the liver, this time they're storing it in the fat cells. They're storing it as triglycerides and as fatty acids inside of fat cells. And what do we call that process? We call it lipogenesis. So the creation of triglycerides or fat. And so what we've got now is we've got insulin, whose job is to take glucose out of the blood, has done this a couple of different ways so far. It's taken some of that glucose and it's turned it into energy. Then it's forced it into the cells so that it can make energy. It's taken some of that glucose and strung it together into glycogen and put it away in the liver for use later. It's also taken some of that glucose and created more triglycerides and tucked those away in the fat cells in our lipocytes or adipocytes, again to be broken down later if we need them. And then one of the other things, the last thing it does, it helps glucose enter into the muscle cells and then perform protein synthesis. Basically, it's taking this amino acids and turning them into proteins. Proteins are just amino acids kind of strung together. So again, it's just another way that we're taking glucose out of the blood and we're putting it somewhere else. In this case, we're turning it into a protein and we're storing it in the muscle. So if you look at that, you can kind of see that insulin will either use glucose or it will store glucose. Regardless, it's trying to get that glucose out of the blood. If it stores glucose, it's going to do it in one of three ways. It's going to do it in the liver as glycogen, or it's going to do it in the fat cells as triglycerides. I'm not going to spell that. Or it's going to do it in the muscle as protein. So if you kind of look over here, and we're going to talk about some of the things that insulin slows down, the processes in the body that insulin slows down. But now, because we understand what insulin does, because we understand that insulin is taking glucose out of the blood, that's its main goal. Then when we look at some of these other words and processes, it's not going to be difficult at all to figure out whether or not insulin is going to increase or decrease these processes. So for example, let's look at this first one, gluconeogenesis. If you break down the word, genesis is creation of, neo is new, gluco is glucose, so this is creation of new glucose. If we create new glucose, where is that glucose going to go? It's going to go into the blood. That's the opposite of what insulin wants to do. Insulin wants to take it out of the blood. So while insulin is doing all of these things to get the glucose out of the blood, it's also inhibiting gluconeogenesis. It's stopping gluconeogenesis from happening. We don't want any new glucose. We want to get the glucose out of the blood. If we look at this second one again, we've got glycogenolysis. Again, breakdown of glycogen, right? So let's walk that through. Where is glycogen? Glycogen, we talked about earlier, it's stored in the liver as chains of glucose. When we break it down, it goes back into glucose. Where does that glucose go? Back into the blood. So is that something that insulin is going to want to do? No, it's the opposite. And so again, insulin will slow down or inhibit glycogenolysis. And again, so we've got these areas. Either the glucose is going to be used or it's going to be stored in one of these three areas. We already just now talked about what insulin does in terms of stopping new glucose from being made, stopping creation of glucose in the liver. Now let's talk about what it will do in terms of fats and triglycerides. So if you look at this word here, again, lysis is breaking up, lipo is fats. So this is the breaking up of triglycerides and turning them into glycerol and fatty acid to create energy. Again, this is not something we want to do. Insulin is already trying to pull all of that glucose out of the blood. We have enough fuel for energy. We do not need to create any more fuel for energy. So insulin actually works against lipolysis. And the same can be said again for the protein breakdown. If you remember over here, we talked about how insulin is going to take all of that glucose in the blood and it's going to store it in the muscles as protein. So if it's taking the glucose and putting it into the muscle, why would it want to break that muscle, that protein down again and send that back out into the blood? It doesn't. So it actually works against that and works to inhibit that. So if you can understand all of those things, and I know that some of these words are, I find that students really struggle with just these words showing up on tests and kind of going, okay, what's that again? Glycogenolysis does this or does that. So if you really just stop, break down the word, know what it's doing, and then ask yourself, really simply just ask yourself, is that going against what insulin wants to do, which is to take the glucose out of the blood and use it or store it? Or is it helping insulin do that job? If it's helping insulin, then it's something that insulin triggers or insulin does. If it's working against that, then it's something that insulin inhibits or stops. And it's really, really important to remember that as we go on and we talk about things like diabetic ketoacidosis.